1 going to explain problem 1, which is mixture 1. Okay, now let's see the specification of the tank. It's a cylindrical tank with a radius of 7.5 centimeter, and then the whole area of the tank is 176.715 centimeter per cube. And then it contains 2.5 liter of brine solution with the mass of 0.5 kg of salt. And then in order to maintain the brine solution in the tanker 2.5 liter, the height of the tank should be 14.15 centimeter. And then the diameter of pipe is 0.1 meter. Now, participant is going to fill the tank with brine solution of 2 kg of salt. So this is a drawing of the tanker in the prototype, and then we assume that the water solution in the tank remains constant. That means the change of water is 0, and then the volume in the tanker has to be 2.5 liter literally, and then the flow rate in is equal to flow rate out, and then we assume that diameter of the pipe in and out is 1 centimeter. This means 1 times 10 to the power of negative 2 meter. So we use the formula quarter pi times diameter square times velocity is equal to flow rate. That means the flow rate in and the flow rate out is the same value, which is 1 times 1.335 times 10 to the power of negative 5 meter cube per minute. And then we assume that the velocity out same with the velocity in, which is 0.517 meter per minute. And then the mass flow rate is equal to flow rate times concentration. And then we calculate the mass flow rate in and then mass flow rate out. We will get the mass flow rate in is equal to 0.0267 kg per minute, and then the mass flow rate out is 5.34 times 10 to the power of negative 3 mass of the salt kg per minute. And then now the rate of change is equal to mass flow rate in minus mass flow rate out, which means 0.0267 minus in bracket 5.34 times 10 to the power of negative 3 mass of salt. And then we rearrange the formula, we will get into this. And then by integrating factor, we have to find out the value of C. We will get AT is equal to 5 plus CE to the power of negative 5.34 times 10 to the power of negative 3 T. And then we use the details given, which means at time T equal to 0 minute, the mass of salt is 0.5 kg. And then we will find out that C is equal to negative 4.5. And then we substitute the value, we will get the original equation, and then in the equation, from the equation, we can find out that at time T equal to 15 minutes, the mass of salt is actually equal to 4.1135 kg. Thank you.